Hello everyone. The topic of this lecture is an overview of project uncertainty analysis in construction engineering economics. We will mainly cover the following 4 parts. 1. The meaning of uncertainty analysis. 2. The reasons for uncertainty factors. 3. The content of uncertainty analysis. 4. The methods of uncertainty analysis. Uncertainty analysis is a crucial aspect of the economic evaluation of technical proposals. Decision-making primarily relies on the economic evaluation of technical proposals, which is based on certain data such as total investment construction period, annual sales revenue, annual operating costs, annual interest rates, equipment salvage value, and other indicators, all considered known and certain. Even estimates or predictions for a particular indicator are deemed reliable and valid. However, in reality, economic evaluations of technical proposals often involve calculations of future economic outcomes, and all future results of a proposed technical proposal are unknown. The data used in these calculations are largely based on analysts' predictions and judgments about future conditions. Therefore, no matter what methods are used for prediction or estimation, they will inherently contain many uncertainties. It can be said that uncertainty is an inherent characteristic of all technical proposals. Although the degree of uncertainty may vary among different proposals, to minimize decision-making errors, we need to understand how changes in various internal and external conditions will affect the economic outcomes of technical proposals, as well as the resilience of technical proposals to these changes. So what exactly is uncertainty analysis? Uncertainty analysis is the process of studying and analyzing how changes in key factors affecting the economic outcomes of technical proposals will impact the economic outcomes of proposed technical proposals. In order to inform sound decision-making, it is an important part of the economic evaluation of technical proposals and should be conducted before making final decisions on proposed technical proposals. 2. The reasons for uncertainty factors. There are many reasons for uncertainty factors, and generally, the main reasons include the following. First, insufficient basic data or statistical bias. This refers to errors caused by original statistical errors, insufficient statistical samples, or inappropriate application of formulas or models. For example, investment in construction and working capital are important basic data for the economic evaluation of technical proposals. However, in practice, due to various reasons, their amounts may be overestimated or underestimated, thereby affecting the results of the economic evaluation of technical proposals. Second, limitations of prediction methods and inaccurate prediction assumptions. Third, changes in future economic conditions. Due to inflation, there may be fluctuations in prices, which will affect the prices used in the economic evaluation of technical proposals, leading to deviations in data such as annual operating revenue and annual operating costs from actual values. Similarly, changes in market supply and demand structures will affect the market supply and demand conditions of products, thereby impacting certain indicator values. Fourth, technological advancements. Technological advancements can lead to the replacement of products and processes, causing estimated annual operating revenue, annual operating costs, and other indicators based on original technological conditions and production levels to deviate from actual values. Fifth, the influence of qualitative factors that cannot be quantitatively expressed. Sixth, other external influencing factors, changes in government policies, the promulgation of new laws and regulations, and changes in the international political and economic situation, can all have certain and even unpredictable impacts on the economic outcomes of technical proposals. Of course, there are other influencing factors as well. In project economic evaluations, it is very difficult to comprehensively analyze the impact of changes in these factors on project economic outcomes. Therefore, in practical work, it is often necessary to focus on analyzing and grasping the key factors that have a significant impact on technical proposals in order to achieve better results. 3. Content of uncertainty analysis. In order to effectively reduce the impact of uncertainty factors on the economic performance of technical solutions, we should improve their risk prevention capabilities, and thus enhance the scientificity and reliability of decision-making regarding technical solutions. It is essential to conduct uncertainty analysis in addition to deterministic analysis. Suppose the benchmark rate of return IC for a technical solution is set at 8%, and the internal rate of return IRR calculated based on the solution's basic data is 10%. Since the IRR is higher than the benchmark rate of return, the solution is naturally deemed feasible according to evaluation criteria. However, making a decision solely based on this is insufficient, because we have not considered uncertainties. For instance, during the implementation of the technical solution, factors such as investment overruns, prolonged construction periods, failure to meet design capacity, rising raw material prices, increased labor costs, product price fluctuations, product selling price fluctuations, market demand changes, loan interest rate changes, etc., may all prevent the technical solution from achieving expected economic results, leading to a decline in the IRR, or even losses. If the IRR drops by more than 2%, the technical solution may become infeasible, posing risks. Ignoring these uncertainties and relying solely on deterministic analysis based on basic data for decision-making may lead to errors. Therefore, to effectively mitigate the impact of uncertainty factors on the economic performance of technical solutions, we should enhance risk prevention capabilities and improve the scientificity and reliability of decision-making. It is essential to conduct uncertainty analysis in addition to deterministic analysis. To this end, based on the specific circumstances of the proposed technical solution, we should analyze the impact of various internal and external condition changes or measurement data errors on the economic performance of the solution, estimate the potential risks and risk tolerance of the solution, determine its economic reliability, and take corresponding measures to minimize risks. This analysis of uncertainty factors affecting the economic performance of a solution is called uncertainty analysis. 4. Methods of uncertainty analysis. There are many methods for uncertainty analysis, with commonly used ones including 1. Break-even analysis, also known as cost-volume-profit analysis. Break-even analysis treats the production and sales volume of a technical solution after it is put into operation as an uncertain factor. By calculating the break-even point in terms of production and sales volume, it analyzes and judges the impact of uncertainty factors on the economic performance of the technical solution, clarifies the risk level of implementing the solution, and its risk-bearing capacity, providing a scientific basis for decision-making, depending on whether there is a linear relationship between production costs, sales revenue, and production and sales volume. Break-even analysis can be further divided into linear and non-linear break-even analysis. 2. Sensitivity analysis. Sensitivity analysis examines the impact of increases or decreases in various uncertainty factors on the economic performance evaluation indicators of a technical solution. It calculates sensitivity coefficients and critical points to identify sensitive factors. 3. Probability analysis. Probability refers to the likelihood of a certain outcome resulting from an event. Probability analysis is a quantitative analysis method that uses probability to study and predict the impact of uncertainty factors on project economic evaluation indicators. In practical applications, the selection of specific analysis methods should comprehensively consider the type and characteristics of the technical solution, decision makers' requirements, available human and financial resources, and the economic impact of the solution. Generally speaking, break-even analysis is only suitable for the financial evaluation of projects, while sensitivity analysis and probability analysis can be used for both financial evaluation and national economic evaluation. That's all for today's video. Thank you.